Good evening everyone and welcome back to my channel. On today's agenda is a short video explaining about aeroplanes and why the factor of charge, so the G's that you feel in a turn, are increased in comparison to level flight, right? So here, for example, on my left, I've got a photo of an aeroplane in level flight with 1 G going in to land at the runway, where I see on my right I've got a photo of the glider, or a video of the glider, just doing a nice steep turn. And yeah, so today we're going to explain why indeed the glider is going to feel a factor of charge that is greater in this turn than the aeroplane that is in level flight. So how do we work on this? So pretty much, to explain this, what we are going to do, we are going to draw a very basic diagram of an aeroplane. So let's just have a circle here with the wings here. Let's just put the rudder here and imagine it's going towards us, right? It's not, the direction is not important, but let's just imagine it this way. And what we're going to do is we're going to look at the forces acting on the aeroplane. So the main force, well, gravity, is going to be acting straight down. We assume the earth is here, right? So that's gravity, so we're going to call it weight. And this gravity, since the aeroplane is in stable flight, so just 1G stable flight, right? It's not accelerating, it's not decelerating, it's not going up or down, it's just staying in level flight. This weight is going to be counted by lift, right? And this lift arrow is going to be exactly the same as this weight arrow, as the aeroplane is not going to be accelerating anyway. And also, obviously, there's going to be drag countering the thrust of this aeroplane. However, for the purpose of this video, we're not going to look into them too much. We're literally just going to be concentrating on this lift and weight sections of the forces, right? So to make our lives easier, we're just going to call the lift 1G and the weight 1G, right? So it's the aeroplane is accelerating at a speed of 9.81 meters per second towards the ground. However, since it is also producing lift, it is staying in level flight. And what we're going to do now is we're going to look at an aeroplane in an angle of bank, right? So let's draw this same plane here. However, instead of being straight like it was, we're going to give it a 60 degrees angle of bank, right? So now this is the rudder, so you can tell it's going that way. Pardon my drawing, but yeah, still facing the same direction. And now we're going to look once again at the forces on it, right? So let's draw the horizon here on the little dots. And since this aeroplane is at 60 degrees banking to the right, this angle here is going to be 60 degrees, right? So what we're going to do is we're going to draw the forces again. So we have the weight still acting straight down as the earth is over here. However, now the lift is not going to be acting this way. It's going to be acting this way, right? Since the wings always produce lift this way, of course. So now what do? We just pretty much just break down this this force. Actually, I probably should have drawn this a bit bigger, since now this force is going to be greater. You'll see why. So we're going to break down this lift force into its separate components. It's perpendicular and parallel components. So we've got a section of the lift that just goes in this direction and helps to pull the aeroplane to the right. And here, let me just draw it properly. And here we have the section of the force of the lift that is helping to keep the aeroplane still in level flight, right? Since this force must balance this one if the aeroplane is to remain in level flight, right? Okay, so now let's have a look. Right, so this is where our old perpendicular was, and this is where our new one is now. So we can say that this angle is also 60 degrees, and therefore we can induce that this angle is going to be 30 degrees, right? You could also have just said, okay, so this here is 60, and by laws of like alternating angles, this is also going to be 60. However, for the purposes of this video, we're just going to stick with this. And then, so we have a perpendicular triangle, perpendicular, a square, like a 90 degrees angle, and what we wanted to see is work out this force X, right? This X is what our pilot's going to be feeling. And how do we do that? Well, we go back to this 1G. So we know that this is, we're just going to call it 1G for now, or like 1, just to make things simple. In reality, it would be the weights, but since we want to compare kind of forces, this they will cancel out eventually. So we'll just call them, stick with 1 at the moment, and simple. And we're going to use a bit of trigonometry. So what we studied when we were like 10 or 12. And let's look at that, right? So we have, so we know we have this angle, and we want to work out this, and we have this, right? So we use sine. So we know the sine of 30 is equal to the opposites over the hypotenuse. So is equal to 1 over x. 1 over x, and now simply just rearranging to give x here. So we get x equals 1 over sine 30. There we go. And what is 1 over sine 30 equal to? Well, sine 30 is simply equal to a half, right? So which gives us 1 over 1/2, which gives us 2, right? So it's going to be 2g. So here we can literally see that we have the pilot is going to be feeling 2g instead of 1 in a turn with 60 degrees. And this actually works with any angle of bank, right? We will be able to see what increased g the pilot will be feeling. Yeah, and that's why is that the case? Well, this is the case because the wings and the engine have to work harder in the turn, because there's this added component of the force, right? This component was not there in this diagram, right? And therefore, since we have this extra component, the wings must work harder if the aeroplane is to stay in level flight. Bear that in mind. And therefore, and since the weight of the aeroplane, since the mass of the aeroplane just does not change, we still have to counter this this downwards force, this weight, and therefore this means that the lift is also got to be the same. And since we have added this extra force, then therefore we have this extra load factor on the pilot. Right, so I hope this made sense. Thank you very much for listening. If you have any questions, as usual, just drop them in the comments below. This is, as I said, a simple video, and thank you very much for watching. Cheers.